is Be Beautiful. Would you like to make a Be Beautiful rose just like this? This is Mixi, and you're in luck. I'll show you how. And of course, we're going to do some science because who are you kidding? This is Mixi. Anyways, to start, I'm going to tell you what you need. You need 2 coffee filters. You need a pair of scissors. You need some scratch paper. You need some water-soluble markers of different colors. You need something to tie off the petals. A piece of wire, a twist tie, some string or tape is great. This is great because you'll see it makes a nice little sepal or calyx for the bottom of the flower. And this is optional, a permanent or non-water soluble green marker to color that and make it look even that more realistic, because we're actually making a little model of a flower. So we're going to learn a tiny bit of floral anatomy when we do this project, and we'll also learn a chemical technique called chromatography. It's used in chemistry as well as life sciences and probably other things too that I don't even know about. The last thing you'll need is a small container. It could actually be a water bottle. The most important thing that's small is you want to have a small opening so that it can hold your rose without the rose falling all the way in. So that's all our materials. Let's get started. The first thing that you want to do for this project is protect your surface, because these markers, actually, you want them to be able to bleed a little bit. And they should also be water soluble. Actually, I'm going to start with the yellow. And so what we're doing right now is we're mixing these pigments, which are colored chemicals, together. We're mixing them together on the paper. And so you'll want to do that. I'm using the center of the coffee filter. There's like a little circle there as the place that I'm going to do that. You actually want to do it right around there. It's the best place for it for this project. And so as you can see, I'm overlapping and mixing the colors, and the chemistry technique chromatography is going to allow us to separate these chemicals back again. And the reason it allows us to separate chemicals is because the chemicals are all different, and so they have different properties. And so how they separate or whether they separate from each other will tell us that they are different, and you'll be able to see that again. So I've done that with just one, but I prepared another in advance. I'm going to take that out. And once you've done that, what you'll do is stack the filters together and fold it over. And then I like to make it into thirds. You can make it into fourths if it's easier, but I like thirds because I think if I make it into fourths, it's too many petals. Although some roses, if you want to be realistic for some roses, they do have lots of petals like that. But many don't. Actually, a lot of wild roses have very few petals compared to the ones that we have hybridized. So anyways, once you've done that, you're ready to cut your petals. And so I make a little heart shape. And so of course this is where the art comes in. If you want to make it a fancy or imaginary fantasy flower, you can. And this itself is not necessarily scientifically accurate, but it does make it look nice at the end. That's something, if you feel like researching, you can do, because there's lots of information about how plant parts are shaped and structured. And so we're making the petals. I don't know, you may not know this, but all the petals together of a flower create what's called a corolla. So that's what it will look like when it's done. And so now this is your sepal for your calyx. These are your petals to make your corolla of the rose. But I've kept one separate. So that is going to be the center of the flower. And what I'm going to do is I'm going to roll that into a kind of tiny little tube. It doesn't have to be perfectly rolled together and actually you want it to be loose at the end. And then at this end where you have the line of color and pigments that you've mixed before, you just twist it. And so what I'm going to now do is just make my flower. So I'm just going to overlap my petals like this. And what I like to do is see where the petal is open, the second petal is open. I like to flip that over and put that like face down into the next petal, or rotate it slightly. And you'll find that if you make a lot of these roses yourself, you'll notice that depending on how you arrange the petals, it looks more or less realistic. And the reason for that is because flowers and plants, they have a very specific structure to them. So sometimes I think a lot of people, you look at a plant and it's just a plant, you don't really think too much about it. But just like human beings and other organisms have a very specific arrangement of the structures of their parts to make it look more real or not, plants do too. And so when you make a rose, you're making a model of an actual plant part, and how realistic your model is, you'll be able to just tell at the end. And so one of the things that makes it more realistic is the arrangement of the petals, which are actually modified leaves. There's even a science that studies the arrangement of leaves and petals and other plant parts. It's called phyllotaxis or phyllotaxy. So if you want to look that up and make a more accurate model of your rose, that's something that you can do. This petal didn't quite separate. It's a mutant. Sometimes we have that in flowers. Actually, you can have a mutant where just a few cells, not the whole plant, have mutated, and it's called an autosomal mutation. Throwing as much science as I can into this 10 minutes because it's fun. I love science. Oh, a lot of these have mutated. I will tell you, as much as you might have a flower that doesn't look perfect or look nice the first time around, it's going to be awesome for science because you'll see something really cool when you do this. So this is a chromatography rose, and to finish it off, you just want to tie it off. You can use tape, but one of the important things for this project to have it work for chromatography is that you have to leave some of the paper free at the end. And so what I'm going to do is just put the wire right up against the base of the corolla. You know, all the petals together are called the corolla, and start wrapping it around. And so this tie, this green part is a sepal, represents a sepal, and the sepals, since there's two of them, there's two ends, the sepals together make up the calyx. And so, and actually even this has a name. Everything has a name in science, if it's known, and this is called the peduncle. The bottom part of the flower that joins into the stem is called the peduncle. It's kind of a fun word. So anyways, now I have my rose. It's a chromatography rose though. So the chromatography part, you're going to put water in your small open mouth container up to a point where the water would just reach the tip of your rose, and you're going to put it in. And what you'll see is that the water is going to move up into the flowers through what's called capillary action. So the water is actually sticky. It's going to be pulled up and stick to the paper, but as it does that, it's going to stick to some of the inks on our water-soluble markers and dissolve in it. And then depending on the ink, the water is going to carry it up more or less, because some of the ink also will stick to the paper. And depending on how much it sticks to the paper versus how much it sticks to the water, you'll see the colors will separate back again, even though you combine them on the paper before. And so you'll end up with a rose that looks something like this. And you can play around and you can experiment with different colors and even how you draw the colors on and see what happens. Hi, I hope you enjoyed the video and it helps you do some fun and crafty science at home. If you're interested in more, check out the link where you can learn how to do another kind of paper chromatography, make your own pH indicators, and also do a photosynthesis test using actual plant material. Be safe and have fun.